Hey folks, welcome back. In our last video, we started transforming the AST to create the kind of output React expects. We successfully tackled the first step by adding an extra import declaration, as you can see here. And in today's video, we are moving to the next step, transforming each tag into a function call using one of these two methods, underscore JSX or underscore JSXS. But let's take it a step further. For the sake of learning, I added some props to our code example so we can dive deeper into transforming those as well. As you can see here, I added class name, a variant size, and a Boolean value auto start. Actually, they do nothing. They are here just to understand the transformation process. So let's get to it. Let's see in the REPL the expected output. As you can see, all the JSX elements are transformed into function calls using either underscore JSX or underscore JSXS. Those function calls follow a consistent pattern and take two arguments: the tag name as a string that represents the name of the element, and the props object, which contains any props passed to the component. There is one detail we should pay attention to it, which is the children prop. If the component has a children prop, it will be included inside the props object, and it could be either a string or an array of other JSX elements. Now, one question you may be wondering: when should we use underscore JSX and when should we use underscore JSXS? Well, great question. The difference comes down to the number of children the element contains. We use underscore JSX when the element has no children or just one single child. This is the default case for simple self-closing tags or tags with a single text child. And we use underscore JSXS when the element has multiple children. All right, let's head over the AST Explorer and see the structure of the nodes. Let's focus on the JSX element. As you can see here, the node has two properties: opening element and closing element, and also a property children that contains other JSX elements or JSX text nodes. Sorry, JSX element nodes or JSX text nodes. When we look into the opening element, we see an attribute property. Each attribute is represented by a JSX attribute node. This node has a value which can either be a literal for static values like strings or a JSX expression. Let's find one here. Here it is. If the attribute is a JSX expression, there is an extra property inside the value called expression that contains the value node, as you can see here, which we don't have for a literal. Along with JSX elements, we also need to handle JSX text nodes, which represent any text inside the tags. It's pretty straightforward. They simply contain text as their value, as we can see here. Well, before we dive into the code, let's outline the steps we need to take for this transformation. We need to target two nodes, JSX text and JSX elements. So let's add it here. Be mindful, the order here matters, and we need to process JSX text before JSX element. You might recall from the previous video that enter and exit apply AST transformation at different moments during the traversal. When you apply a transformation at the enter function, you are modifying the AST nodes as they are being visited. This is useful for making initial changes or adding new nodes before the code is fully processed. On the other hand, transformations in the exit function are applied after the node and its children have been fully processed. This is ideal for final adjustment or cleanup tasks, ensuring that your transformations account for the complete context of the node and its subnodes. For our purpose, exit is more suitable because it provides access to the parent context of any child before finalizing the transformation. So here for the JSX text, what we want to do, we need to check if the node contains formatting new lines. As you can see here, there is almost all the JSX text node contains only new lines. Where is it? As you can see here, there is only one that contains text. Well, to simplify the processing, as it's only for formatting and does not affect the logic, I decided just to remove them. So here the logic would be simple. Check if the node is a formatting one. If it's the case, remove it. Otherwise, return the text value. On the other hand, for the JSX element, it's a bit more complicated. If you see in the REPL what we want to achieve here, this function calls, we need to extract the tag name as it serves as param for as argument for the function call. We need to build the props object from the JSX attribute. As you can see here, that contains the props or the children of both. Well, we build first the props from the attribute, then we build the children array. Then we construct the function arguments. Then we generate the function call using either _JSX or _JSXS. And finally, we replace the current tag with the node created or the AST equivalent for the function call. So let's get started. When implementing this function, I discovered actually the built-in trim function in JavaScript not only removes leading and trailing white spaces, but also handles line breaks. So it's very useful in our case. I only check if the text actually is empty after applying the trim function. If it's the case, I use the helper remove. Otherwise, I create an AST with the value, a string literal, and replace the current node. So we may log it to see what does it look like. Path, I believe. Well, I will just remove this console log. We don't need it anymore. And let's log the node using JSON-stringify to have some formatting. So it's I would put null here. I believe it would be better like this. Up. As you can see here, yes, we have a string literal, an object, which is that represents actually the AST, a string literal of type string literal, and the value hello. So that's great. And for the other cases, it's null because we removed the node. Perfect. Now let's tackle the JSX elements. This is the main part actually. Well, to get the tag name is quite easy. I will just check the open-end elements. It has name.name. We can see it in the Explorer. Let's see any JSX element. This one, for example. You see, if you explore, you go open-end elements. Name, which is a JSX identifier, and name. That's the structure of the opening element. So yeah, that's pretty much it to get the tag name. And let's tackle the other steps. Well, for a better readability, I will create a helper file and will add functions to process those steps. Yeah, let's put it here. We have a helper function build props that will give us our props object, representing the attribute, one for building the children, one for building the arguments for the function call that combines props and children, and one for creating the call. And the last step is replacing the node. This one is straightforward, just call the helper replace with. So how do we build the props? Or how do we process the attributes? Well, the JSX element node has an opening element property which contains attributes. The attribute structure is as follows. Each attribute has a JSX attribute node which has a name and a value. As you can see here, the value can either be a literal, like a string, or a dynamic expression. We have an example of a dynamic expression. Let's see here. Not this one. Yeah, this one. Well, the logic here is simple. We grab the attribute from the opening elements. We loop through each one to get the key and the value. The key, we can have it from this property name. And the value depends on the type of the node. If it's a JSX expression, we need to grab the expression property from the value. Otherwise, we just get the value. Let me show you the code here, or the AST format. As you can see here, either we grab the value, which is a literal node, or in the case of JSX expression, actually the value has an extra property expression that contains the value that we want. There is another case, it's the third case. It's when the property is a Boolean, but without any value, which is the implicit true value. In this case, the value is null, so we need to handle it as well. So when an attribute has no value, it means that is a Boolean. For example, like here, it's auto start. This one, this node will have no value. Let's see it in the AST. Yeah, so as you can see here, the value is null for the attribute auto start. So to handle it, I just check if the value is null. Well, here, if there is value, we do our processing. Else, when the value is null, we just create a node for a Boolean literal with the value true. And then we need to create an object property for the AST using the Babel type helpers. So this one, object property, that takes two arguments. The first is the key of the property. It should be an identifier. and then the value, which is already an AST node. We don't need to use any helper here. So, and we get back our props as an array. So we can here, let's do a console log here to see what does it look like. And yeah, let's test this. Now it's better. Okay, as you can see, we have some object properties here, so it looks fine. We have an array of properties. Let's continue. So the next step, the third one, is to handle the children of the tag. Children can either be a text like hello world or other JSX element, or a mix of both. In the AST, children pop is represented as an array, but if you check the expected output, it's not always the case. It could be an array in the case of multiple children, or a single value, as we can see here, when we have just one child. So our logic should handle this transformation. So first we grab the children pop from the AST, from the node. If there is no children, we just return undefined, nothing to add to the props. If there is one child, here we create an object property with the key children, and we affect directly the node instead of the array. And we return the node created, or the last case where we have multiple children. In this case, we create an array expression for those children. And that's pretty much it. Let's log it and see the format or the result. Well, it seems that we have some nodes here. We cannot be sure they are correct, but yeah, at least we have something. We will check at the end if everything is working as expected. Now that we have built both props and children, it's time to bundle them together into one argument for our function call. Well, the logic here is quite simple. First, we create an array called args. We do so because eventually we need to pass those properties to the Babel helper object expression to create the AST for the object, the props objects, the final props objects, I mean, that contains all the properties, all the attributes. So if we have values in the props array we passed that are coming from the step before, we just spread it and push it. And if we have children, which is one property actually, we push it as a final item for the args array, and then we return the AST for the object created. And that's pretty much it. And finally, we need to use everything we have built so far to generate the function call itself. To create a function call, there is a helper called callExpression. It takes two arguments. Let me just format a little bit to ease readability. Okay, first it takes as argument the first one, the identifier, which is the name of the function actually. And then it takes as an array all the arguments we want to pass to this function. The first one, it should be the tag name, actually the AST of the tag name, and then the object argument we created before. As you can see here, we have a function call. The first argument is the tag name, and the second one is an object with the properties that represents the children and the attributes. And let's put the output here to see if it's working as expected. There is an issue here. I forgot that we don't have an identifier. Actually, the identifier should be either underscore JSX or underscore JSXS. So here our logic is not quite completed. For the sake of testing, let's add a default value to the identifier just to see if it's working, and then we will fix our logic to get the correct value. Okay. Oh, that's nice. As you can see here, we have a function call. We have here the tag, some props. Oh, it looks good. So it seems to be working as expected. That is great. So now we have just one step left, is to choose which identifier we need to use. Actually, the identifier JSX or JSXS is related to the function arguments and depends on children. In my opinion, the best place to set it would be within the build function args helper here. So let me move this here. What we can do is set a variable called identifier, and here when we check for children, we can add a logic to check if this children value is an array expression and has more than one element. In this case, we switch the value to the JSXS identifier. Well, here we need to change the signature of our function. Let's return an object. We return args, an object with args is the same value as before, and we add the identifier. So we need to change it here as well. So now we get args and identifier, and we need to pass the identifier to our helper build function call. So let's add a helper to write a file. Let's call it a write file. Simply write file. It takes a file path and the content, and just create the file. If there is an error, it logs the file could not be saved. If it's not, if everything went well, it says that file is saved. Well, pretty straightforward. And now I need to call it. Actually, what we need to write is the content of a code property within the output, and let's import it here. So with this, I think we're ready to go. Let's give it a try. Oh, I did not import the FS model. Now it should be okay. Fantastic, it says file saved. Let's see the output here. And it's working. I'm super happy with the result. As you can see here, we have the div, the first call. It's using JSXS as it has multiple children here, an array of children. and each child is a function call as well. The JSX element was transformed. Here we have the counter with the one property auto start. Here we have title with two properties variant size, and our text hello world as a child for the h1 tag. And this is pretty much it. Now we have successfully transformed our JSX to pure JS. Well, of course, this implementation is naive. It doesn't handle edge cases. It's simplified, but it gives a great idea how things are working under the hood. Now there is just another step here. We need to apply this transformation to our other component, title and counter. This will be the subject of the next video. So thanks for watching and see you in the next one.